Today we're in section 9.4. The title of today's lesson is real numbers. And so I think we do immediately think what? Okay, well, what's the opposite of a real number? A fake number? Like, is there even such a thing? And there's not. So every number, any number in the entire span of the universe is a real number. But under the umbrella of real numbers, we have two categories, rational and irrational numbers. I want you to write that on your notes. So make like real numbers kind of like your overarching category, and then underneath I want you to put rational numbers and irrational numbers. We have two categories underneath real numbers. Okay? Rational and irrational. We're going to talk about what kind of numbers are rational and what kind of numbers are irrational. Here's what I need you to write under. We're going to start with irrational. Irrational number neither terminates nor repeats. What does that mean? The decimal does not terminate and does not repeat. Okay, so over here, even on the whiteboard, I have one written. I'm going to try to write one maybe above this wording right here. But basically, when you put it in your calculator, you would have a number like 2.1452636, and then it just keeps going. All right, like your calculator screen runs out, but you still have no pattern that's shown. That would be an irrational number. That decimal value does not terminate and it does not repeat. And that's it for irrational numbers. For irrational numbers, like that's the only criteria. Then you have rational numbers. All right, and here's what you need to know about rational numbers. Rational numbers can have a terminating decimal. What does a terminating decimal mean? Let me actually just switch gears over here so I can write this down. All right, so underneath rational numbers, here's what I want you to write. Terminating. All right, a terminating decimal would be like 2.456. That decimal ends. It might go out 3 decimal places, but it still terminates. It ends. It doesn't keep going. A repeating decimal is rational. Repeating decimals are rational. Here's a repeating decimal, 1.3333, and as far as your calculator screen will show, the 3 keeps repeating, so you would write it 1.3 repeating. Repeating decimals are rational. You can say that they're rational because they have a pattern. There's a pattern there of the repeating numbers. Rational numbers are whole numbers. And rational numbers are integers. Here's the common misconception, though. What's the difference between a whole number and an integer? Because a lot of times when we're asked to describe an integer, we say whole number, right? An integer, let's give some examples. -5, 3, 8, -15. What do they all have in common? They are, and the temptation is to say whole numbers, but they are numbers that do not have decimal values. Okay, that's what we're going to say. Integers do not have decimal values. So some integers, like we just said, -7, 15, -8, 12, and the list can go on and on. But these numbers do not have decimal values. That's different from whole numbers. Whole numbers are only positive. And I mean, guys, there's an infinite number of examples. But the difference between a whole number and an integer is a whole number can only be positive. An integer can be positive or negative, but neither one of them have decimal values. And what are we talking about here? All of these types of numbers are rational numbers. They're rational. Okay? So rational numbers, that's kind of like the bulk of my numbers over here, right? And then irrational, that's just my crazy numbers that don't have any pattern. They repeat, they never end, they just keep going and going and going. Right, so any questions about rational and irrational numbers? And this chart just basically sums up everything that we just talked about. The fact that you have two categories, and then what numbers belong in each category. We just gave maybe a little more of a detailed breakdown of that. Any questions on rational and irrational? All right, so in the first section of today's notes, in example 1, it says, tell whether the number is rational or irrational. Well, here's the deal. You can't just say rational or irrational. You have to have some proof. Well, in order to determine that, I need to know, especially because all my definitions dealt with decimals, right? Or how do I know if it's repeating? I need to see the decimal version of it. How do I know if it's a terminating decimal? I need to know the decimal. So what I do for all of these terms is I need to convert them to decimals so I can see exactly what's going on. All right, so go ahead and change 2/3 to a decimal. Make 2/3 a decimal on your notes. What's 2/3 going to be as a decimal? And what is it? Is it 0.6 repeating? I think that's right. Okay, so 0.6 and the 6 continues to repeat. Oh, where is it at? There we go. Okay, so here's what I'm going to say. 0.6 repeating, but now you are going to clearly state that you acknowledge that this value is a repeating decimal, and because of that, it is rational. All right, so repeating tells me, okay, you recognize the numbers repeating, and then you also recognize that repeating decimals are rational numbers. Okay, so let's go ahead and do square root of 100. What's the square root of 100? 10. And what kind of number is 10? Is 10 a repeating decimal? It's a whole number. Now, it's also an integer, isn't it? So really, either one of those descriptions would fit it. It's a whole number, so therefore, it is rational. I want you to try the next one. Square root of 6. Write it as a decimal, then describe it. What kind of decimal is it? Is it repeating? Is it terminating? Is it non-repeating or non-terminating? And then because of that, what kind of a number is it? What category does it belong in? So what is the square root of 6 as a decimal when you convert it to a decimal? 2.449489743. That doesn't sound like a terminating decimal to me. You say, well, it terminates on my calculator. No, it doesn't. Your calculator screen just ran out. There's no pattern, so this is what I would call a non-terminating, non-repeating, irrational number. Irrational number. Okay, and the ... means that those numbers actually do continue. So the last one is a little taste of what we learned in 11.2, meaning I'm taking the square root of a fraction. There's two ways you can do this, but just to kind of stay consistent, and especially because sometimes you might be able to take the square root of one side but not the other. Does anybody remember what I can do here when I'm taking the square root of a fraction?
Square root of the denominator.
Very good. You can split it off, right? You could take the square root of the top and the square root of the bottom. In this problem, since both are perfect squares, I could have done it the other way where I just take the whole square root. But if the top, let's say numerator is not a perfect square, but the denominator is, then it would be a good idea to split it. Okay? So what is the square root of 16? 4. 4, right? Because 4 times 4 is 16. And what's the square root of 25? 5. So now that I've written 4 over 5, can I tell if it's rational or irrational?
Yes.
As a fraction?
Yes.
No. Even though, okay, you might even have it memorized what 4/5 is as a decimal, you have to show me that step. So convert it over to a decimal and then tell me what kind of a decimal is it, and then what kind of a number is it. All right, so what decimal value did you get? 0.8. So is that a whole number?
No.
No. What is it? It's a terminating decimal. It doesn't repeat. It's a terminating decimal, so I'm just going to write terminating. And then, since it's a terminating decimal, what kind of number is it? It's rational, okay? So does everybody understand what we're doing here? We're identifying, okay, what kind of a number is it? And because of that, what category does it belong in? Okay, so it's kind of sticking with this same concept. We're going to now move to example 3. We're not going to do example 2. Actually, I'm sorry, we're not going to do example 4. We are going to do example 2. So in example 2, we're comparing real numbers. The square root of 2 compared to 9/5, using less than, greater than, or equal to. So right here, as it is now, can I compare them? Can I know? No, I can't. They have to both be in the same format. Well, I don't want to convert 9/5 to some type of a square root. That wouldn't really do me any good. Converting it to square root of 2 to a fraction wouldn't do me any good. What do you think you're going to convert to?
Mixed.
Nope. What are you going to convert to? To compare them, you're going to convert both of them to decimals. So in order to compare, okay, across the board, guys, we have to compare in the same unit. So we're going to convert everything to decimals. Then we can see what our answer is. Okay, so the square root of 2 is what as a decimal? What'd you get? 1.414, and it just kept going. Okay, assuming usually we don't have to go more than 3 decimal places out to see which one's bigger. Okay, so 9/5 as a decimal is what? 1.8. All right, so now that I have them both as decimals, I'm going to start in the largest place value to compare. So I have a 1 here and a 1 here, so it's a tie. So what do I do when it's a tie in the largest place value? I go to the next place value. Now I go to my 4 and my 8. Clearly, which one's bigger? The 8. So that means that 9/5 is greater than the square root of 2. Or you could read it left to right and say square root of 2 is less than 9/5. So you start in the largest place value and you work your way down until you get to different numbers and you pick the biggest one. All right, so that's how we copy and complete using less than, greater than, or equal to. All right, so that leads us into example 3. You will have a question like this on your quiz on Monday, okay, where we are ordering real numbers. So here we have this set of numbers. 4/3, negative 2.8, the square root of 3, and the negative square root of 5. I will not ask you to do the number line, okay? So we don't have to do the number line, but we do have to order them from least to greatest. All right, we do need to order them from least to greatest. So how do we do that? Convert everything to a decimal. Oh, well, conveniently, one of them's already a decimal, so that's nice. But now I need to convert the others to decimals. And guys, I would challenge you to keep them in the same order so you don't get them confused, like which one belongs with which. Okay, so 4/3 is what as a decimal? 4/3 is going to be 1.3 repeating. Negative 2.8 stays the same. What about the square root of 3? What's that one going to be? 1.732. Okay, usually we don't have to go more than 3 decimal places out to compare. And then what about the negative square root of 5? Negative 2.236. Okay, did everybody get those decimal values? We convert them to decimals. Maybe you don't have a calculator? Well, yeah, that would probably be a problem. Okay, all right, next time ask to borrow one. Okay, so now we can clearly see out of these numbers right here, which one is the smallest. Be careful, we have negatives. Which one is the smallest? negative 2.8. Okay, that would be negative 2.8. So the farther we get from 0, the smaller the value, the lesser the value, right? So negative 2.8 is my smallest, and because in the original problem it was as a decimal, that's my answer. Now what comes next?
Negative 5 square root.
Yes, negative square root of 5, because that value is negative 2.236, but I have to write it as negative square root of 5, the original format. All right, let's do the last two. Go ahead and put the last two into your answer in their original formats, if you haven't already. All right, what did you get?
4/3.
Yep, 4/3 and then square root of 3. 4/3 and then square root of 3. So that's how I would put them in order. All right, so you will have one of these on your quiz, and then you'll also have one or two on your quiz where it says, is the number rational or irrational? And then you have to tell me why. Okay, and that's what you need to know from section 9.4.